Heyo! If you use C# with Godot, you may find the general lack of tutorials to be pretty disappointing, especially considering that there are plenty of GDScript tutorials available. Luckily, you can translate GDScript to C# without too much trouble, which is useful for following GDScript tutorials when you want C#. The code that I have here is some simple platformer code that I made. Nothing fancy, no coyote time or anything, but it does have acceleration and deceleration and animation changes. Now, the first thing that you'll want to do when you translate GDScript to C# is figure out exactly what it's doing. So what I'm going to do then is go through and add comments to the code where it's needed. The reason I didn't already comment this code is because oftentimes you may find that code you want to translate doesn't already have comments in it. So, to start, these are the variables, of course. We don't know yet what they do exactly because we're not, looking at that yet. This is a reference to gravity defined in the project's physics settings. You can see physics project settings. It gets the default gravity as a float. And these two variables are references to the animation player and the sprite 2D nodes within the player scene. To animation player and sprite 2D nodes. And here, this runs every physics tick, which by default is 60 ticks per second, but that can be changed in the project settings. So the first thing, every physics frame, is that we check if the player is, if they're not on the floor, then that means that gravity should be affecting them. And also if they're currently moving downwards, then they should play the falling animation rather than, say, the jumping animation. The floor to correct. And then we want to all right, and then here we want to get horizontal input, which is what get axis does. It gets either horizontal or vertical input, depending on whether you put left and right here or up and down. By the way, I forgot to mention these are string names, these weird looking strings that are green instead of the normal orange, because they have the ampersand in front of them, and the play animation takes string names as well as get axis, so they function almost identically to strings. And you could even just put strings in these. I didn't, because I don't really like to. Input. Now here we want to check if the input. Let's see if the input is left here, and the player is on the ground. Then play the running animation, and then no matter what, even if they're not on the ground, make sure that the sprite is flipped the correct way, which would be left, which would be flipped. So So here we want to do pretty much the exact same thing, except it is if the input is to the right. And almost the same thing here as well. If the sprite is flipped instead of is not already flipped. And then otherwise, and it's still on the floor, then we want to just play the idle animation. Now here, we check if the jump button was just pressed and the player's on the floor, and then we apply some negative vertical velocity to it, and also play the jumping animation. Then we use the move toward function to apply some acceleration. So some horizontal acceleration anyways. Finally, move and slide is in every character body 2D and I think 3D as well. It just applies velocity to the character body basically. Okay. Now, so now that we have a somewhat decent idea of what's going on, we can begin writing the C# script. To begin, there are a couple of resources that we need, those being the Godot documentation and the search engine of your choice. Now we can begin. So I will go through and I'll write the script from top to bottom, explaining as I go. Cool thing with Godot 4, by the way, you can pop out the, well, not 4, sorry, it's like 4.1.1 or something that it was added, but you can pop out the code specifically, which is pretty handy. But before then, what we need to do is we need to add the C# script. What? That was weird. And then there as well. So now I have these side by side. I have the C# script here and then the Godot script here. So we're going to get rid of everything in this function, get rid of all of these. And we'll start. So we want to add a float called speed. a float called Excel, and a float called jump velocity. And I'm not going to use snake case in C# because I guess that's just what you do. 750F. This one is 100. $1,600 F. Now you'll notice that these ones are export variables, meaning that you can edit them in the engine itself. When you click on the player, they'll show up right here. So to get that behavior, what we want to do is, in C#, it's a little bit different. You put brackets, export. And then this is something that you would know by looking up how to do export variables in the docs. For example, I know that's not going to show up there because that's going to be about how to export your project. So try @export maybe. Yeah. So then it shows the differences. This is actually a super useful page here, the C# API differences to GDScript. There's just a great deal of things that they thought of that you might not know the difference between the two languages. So super useful. So we're going to say float gravity equals project settings dot get setting. Usually when you want to put when you want to use a variable, or sorry, a function in C# that's in GDScript, it's very similar. It'll just be in this capital case or whatever it's called instead of the snake case. So this is going to be the same, so we'll just copy and paste that. Whoops. Okay, what's the issue here? Cannot implicitly convert type Godot.variant to float. So, cannot implicitly convert type Godot.variant to float. So we need to convert it. That's pretty easy. You just say, actually this is float. And then it believes you like a fool. Now here we're going to put in the references to the animation player and the sprite 2D nodes. This is going to be a little bit funky because C# doesn't really have this onReady tag. You have to make the variables and then actually assign them in the ready function. So that's basically what onReady does, just without you having to do all the hard work yourself. But in C# we do have to do that hard work. So it's going to be a public override ready, and we'll just have that there ready for us. So first node is the animation player. It's equal to I don't remember the syntax, so I'm going to look it up here. I think it is just get node. No, that doesn't feel right. Yeah, right here in this API differences to GDScript. It talks about the onReady annotation itself, and it says instead of doing this, you have these lines of code, and then this one's in the ready function. So we're going to make a private animation player, and it's going to be called animPlayer. We just need to get rid of that. And then we need a private sprite 2D called sprite. Now in here, we're going to say animPlayer is equal to get node animation player, and then the path in the engine is going to be from right here. It's just animation player. There's no because it's a direct child of the player node itself, which has the script. So we're going to say animation player because that's the exact name of this. And then we do the same for the sprite. Yep, that's how you spell it. So now that's all that we need for the ready function. I'm going to go ahead and minimize that so it's not distracting us. What is this? Why is that there? Okay. And now we have the references to the animation player and sprite 2D nodes. And now we're going to do everything in the physics process function, which runs every physics tick, as I mentioned. So the first thing is that we want to check if the player is not on the floor in order to correctly apply gravity. So it's the good old if statement. Once again, the functions are pretty much identically named, just with a different case capitalization or whatever. Oh, that's right. So in C#, you can't edit the velocity variable here directly. You can, so what we're going to do instead is we're going to make a variable called velocity, but it's lowercase. And we're going to say it's equal to the velocity that's a part of character body 2D. And then at the end of this function, we will reassign velocity to the other velocity. So if not is on floor, velocity dot y plus equals gravity. Pretty much identical to the GDScript. And then here we want to say, we want to have another if statement. And this time it's going to check if velocity dot y is less than or equal to 0 in order to check if it's falling downwards. And if it is, animPlayer.play. And now we get to string names. What you can do, like I mentioned in Godot GDScript, you can just use a string and it will work perfectly fine. Same goes for GDScript. In C# you can't just put the ampersand if you want, though. It's not going to work. You have to cast it to a string name like that. Functionally, no difference. So I'm just going to use just regular strings, and then the engine will cast it automatically for us. So now that we're done with that, we need to get horizontal input. And that's going to be a float called direction, just like in... Why is that green? Oh. Just like in the Godot script, a GDScript. Those are the name of our input actions, left and right. So now we want to check if input is left and the player is on the ground. Then we're going to play the running animation. So if direction is less than 0, if it's on the if the player's on the floor, then we're going to play the running animation. And if it's not already flipped, then we're going to flip it so that it faces the correct direction. I forgot how to do comments there for a second. That's a little bit embarrassing. So if sprite dot flip h is not equal to true, meaning it's false, then set it to true. And then after that, we do almost the same thing, except if input is right. And then else, or elif is the same as else if, of course. And then direction is greater than 0. If it's on the floor, play the running animation. I can't see. And then if the sprite is flipped this time rather than not already flipped, then we're going to want to unflip it. Say unflip here. So if it's not equal to false, which means if it's true, if it is flipped, didn't do that right. Then we want to set it to false. We want to rectify that. Where are we? We are here. Otherwise, if the player is on the floor, play the idle animation. So, nope. If. Now, if the player is on the floor and the jump key is pressed, so we want to get input sorry, that's the wrong bracket. Dot is action just pressed, specifically the jump action, and in C# that's a double ampersand instead of the word and, though I'm sure if you like using C#, you already know that. And it's on the floor, then we're going to want to apply negative vertical velocity and play the jumping animation. Negative jump velocity. Next, we do this line where with the move toward, say velocity dot x. This lets us do acceleration. Oh, there's no move toward thing. That's interesting. So let's figure that out. So this is where we Google or search in your search engine of choice. Godot C# move toward. Move toward in C# Godot engine Q&A. Move toward is a method of vector2. We're not using the vector2 version of move toward. We're looking at the float. Aha! The mathf library has a move toward function that is based on a float instead of a vector. So we're going to want to use mathf dot move toward. Yep, there it is. Then we'll say velocity.x. Speed times direction and excel. Now the last line, pretty much every moving character body has it. Move and now, moment of truth, we're going to check if this works. So reload so that that's newer on the disk. Check to make sure. Fantastic. Just want to make sure, yep. And Yeah, they both link to player.cs, both of those scripts. So here we do this. Okay, now that's interesting. The animation is playing, the running animation. However, it's not moving. So let's fix that. What's gone wrong? Move and slide should be working. I remember velocity. Velocity with a lowercase v is a temporary variable that we set up because we can't change velocity with an uppercase v. So we just need to do this. We're going to say velocity equals, oh, there it was for a second. Velocity equals velocity. Easy peasy. Now we're going to check. And just like that, it is working. So that's almost everything that I have to say. However, I want to go back to this mathf function, or not function, library, because I want to say that one of the things that you might run into is whenever you're trying to put a function down in C# that you see in GDScript, you might not see it, of course. However, it won't always be under mathf, because that's only math that pertains to integers. There's also a math library with no f, or sorry, I meant floats. There's also a math library with no f, and there's also a math I library. There might be more, I'm not certain. But just keep in mind you don't be afraid to Google, whatever you need. Whatever you're having trouble with, I mean. So now I'm going to close out of this. And when you close out of the script window, it just goes back to here so you can open it again in the script tab. So now we have a GDScript version and a C# version, and they both work perfectly. Thank you so much for watching. My next video will probably not be a tutorial. I've been exploring fun simulations and games online, especially the ones by Nikki Case, link in the description, and I've been wanting to try and replicate some of them as a sort of test of my skills. So definitely won't be a tutorial. Anyway, bye.